So question 7 seems a little bit unfamiliar. No, we have never done anything like this, but that doesn't mean you shouldn't be doing it. So we're looking for a point that's closest to the origin. So if it comes down to maximizing or minimizing something, we're going to be minimizing here, and what we're doing is minimize the distance. So I'm going to call that capital D, and I'm looking for some point, xy, and I'm looking for to minimize the distance between that point and the origin. Well, the distance between any 2 points is found by using the distance formula. So we're going to have x minus 0 squared plus y minus 0 squared. So our objective function at the moment is just x squared plus y squared. But we also know that for any single point on this line, y is going to be equal to 4x plus 7. So now our distance formula can just be written in terms of x squared plus 4x plus 7 quantity squared. Okay, so we're looking to minimize this function. And it does also behoove us to look at the domain. Where could x be? Well, this is a line. X could be anything from negative infinity to infinity. And one thing, it might, before we even dig in, it might even be helpful to look at what's going on at the endpoints. And again, I can't plug in negative infinity, don't even try, but you can take the limit as x approaches negative infinity. And if I was going to plug in negative infinity and square it, plug it in here, multiply by 4, add 7, and square that, that's going to give me a very big number. It doesn't matter that I'm taking the square root, that's still infinity. And the same thing is true as x approaches positive infinity. If I was going to plug that in, I'd get infinity as well. So we know that if we're going to look at what the graph of this looks like, if I was going to imagine that, on either end, it's going to positive infinity. So let's see what sort of critical values we have. So I am going to, I guess, work this out a little bit. Now I'll just take the derivative. I'm going to write this as x squared plus 4x plus 7 quantity squared to the 1/2. So then the derivative, or dd dx, if you want to do that, the derivative is going to be 1/2, that thing, the inside, to the negative 1/2, and then we need to multiply by the derivative of the numerator, or the inside, so 2x plus 2 times 4x plus 7 to the first times 4. So let's clean this up a little bit. In the denominator, we're going to have 2 times the square root of that thing, 4x plus 7 quantity squared. In the numerator, let's see, here I'm distributing an 8. So I have 2x plus 32x, so that's 34x plus 56. Okay, so there's our derivative. And we will have a critical value at some place where the derivative is equal to 0 or is undefined. I know the derivative will be equal to 0 when the numerator is equal to 0. And that's going to give us 34x equals negative 56. Let's divide both by 2, so that gives us negative 28 over 17. So we have one critical value. And no matter what is going to happen, I know that this is going to give me some sort of an absolute min, my one critical value. But I am going to do a little sign analysis just to justify that. Okay, so this is d prime. I'm going from negative infinity to infinity, right? So I'm not even restricting the domain. I'm just going to put in a 0 over here. Let's call this negative 28/17. And if I take any number that's greater than negative 28/17 and plug it into my first derivative, well, in fact, I know I'll always have a positive number on the bottom. And if I plug something that's less than negative 28/17, maybe negative 100, I know that will give me a negative. Oh, the other thing, I should have wondered about where the derivative is undefined, because that would give me another critical value. But I'll just go back and say the derivative is never going to be undefined, because x squared and 4x plus 7, no matter what happens, this is going to be a positive number. So the denominator can't possibly be equal to 0. Okay, so here's my sign analysis, and I'm not going to write out, but I should write out, but I'll say, since d prime is negative between negative infinity to negative 28/17, so d prime is negative over here, and d prime is positive from negative 28/17 to infinity, we know that at x is equal to negative 28/17, there is an absolute min. And they ask us for the ordered pair. So if this is our x value, well, then y is going to be 4 times that thing, right, plus 7. Goodness gracious, what a pain in the neck. So this becomes 4 times negative 28, right, 4 times negative 28/17, plus, I know I'm going to have 7 times 17. Well, look at that. So that gives me, how does this happen? 7/17. So our ordered pair is negative 28/17 and 7/17.